I'm from Yara Marine Technologies. We used to be known as Green Tech Marine. Company was founded in 2010. We've supplied scrubbers, have them operational since 2012, so we have tens of thousands of operating hours on scrubbers and experience on it. We're also now then become part of the Yara Group, which is a large Norwegian corporation, turnover around $15 billion a year, and about 10,000 employees. So that's us. We cooperate with INTERTANKO here in Greece. I'm very happy about the presentation from Lloyd's because she showed you a chart with green and yellow and red. When does it pay to have a scrubber? And being a scrubber supplier, we have very often come across this question. So we have simply developed a calculator where you can input your own values. So what I'm going to do is to take you through that calculator and show you how simple it is to get a general idea. It's not the answer to everything, but for your initial investigations, whether you should do something or not, this is a very useful tool. So, as mentioned by my honored predecessor, you need to input some stuff in order to have an idea whether it pays to invest in scrubber technology. To do that, you should go to a scrubber manufacturer and ask for a quote instead of guessing on the equipment cost. You can ask many of us. You also need to establish what the installation costs. Now that is very often something a yard can answer. I've heard anything from 50% of the equipment cost, which no ship owner is believing at all, up to twice the equipment cost. So for the sake of the exercise here, I've put in 75% of the equipment cost as installation cost, you see up here top. Then it's your own internal interest level. What's your requirement? What interest level do you calculate in your company? I can't answer that. You can put it in. Then, as also mentioned previously, very important, how much do you sail inside an emission-controlled area? Then you need to input sulfur content in the fuel and some cost level on the marine gas oil and the HFO. The example here is, no surprise, it's a vessel that is in the ECA zone in Northern Europe all year round. It has a fairly large engine configuration. We're talking here about one main engine and 4 auxiliary engines. Total maybe around 28, 30 megawatts of engine power installed. The average load on this vessel through those 365 days is 22 megawatts. And when they are, as mentioned, in coastal waters, maneuvering where there is no discharge allowed and they have to operate in closed loop, they have an average load of about 6 megawatts. And there's about 120 days of those, so 1/3 of the operating time is spent in no discharge waters. And then finally, this owner has to know what is the specific fuel consumption or fuel oil consumption for the vessel. That has to be an average number. It's not so easy to come up with, and if you ask engine manufacturers, they often give you a number that is slightly lower than what real life shows, but some number has to be put in. I hope you're all clear on the preconditions, and your payback time for investing in a scrubber under these conditions is less than a year. So we're in the green range. But with this tool, you can input your own values, and you can check for yourself. Interestingly enough, as I said, it's very often difficult to know how many grams per kilowatt hour that your engine is consuming in terms of fuel. What you very often do know is how much fuel do I buy for that vessel through the year. So therefore, there is a variety in the calculator. You recognize all the data, but what is in here, instead of the specific fuel oil consumption, is your tonnage of fuel per year. With this calculator, you can play around with the parameters specific for your vessel or your vessels and get some sort of idea. I stress it is not the final answer, but it will tell you, is it interesting to start looking at this? Because it's very hard when everybody else says, if you're 25% in the ECA, it's not valid, it doesn't pay. If you're 40%, it maybe pays. Well, with this tool, you can check. Also in this tool, as said by my predecessor, you have to use an alkali to operate in closed loop because the water is losing its buffering capacity, its capacity to take up SOx. We would strongly recommend not to look at caustic soda as an alkali for the reasons stated. Caustic soda is, let's say, harmful. The alternative, magnesium oxide, is completely harmless. A second point, which is just as important, is that your consumption of magnesium oxide is much less. I won't go into the details why, because I'm not a chemist, but the chemists can tell you why. It's a much more efficient reagent than caustic soda. So your consumption in terms of volume is about 1/4 of what it would be with caustic soda. So the higher efficiency also yields a lower storage space requirement on board for your alkali when operating in closed loop. Prices for those two alkalis are historically fairly similar, but caustic soda is varying a little bit more up and down than magnesium oxide has been doing historically. But they are, again, historically, more or less on the same price level. And the cost saving by using magnesium oxide in this vessel that I gave you an example for is actually quite substantial. As you can see from the calculations here, you save about $200,000 per year for that specific vessel. But again, that's something that the calculator will come up with if you input your own values. Now, surprise, surprise, I took a vessel that obviously it was called a no-brainer, that you would absolutely consider to invest in scrubber technology. So let's take a Ro-Ro vessel or something like that that's going in a liner around the world. That gives you slightly different figures. Let's say that also for a Ro-Ro vessel, this load, the 22 megawatt, is quite realistic. The distribution of engines is quite realistic. All the parameters here are quite realistic. But, of course, a vessel like this, if it trades 80 days, and that's maybe all, 80 days per year inside an emission-controlled area, at least pre-2020. When we get to 2020, and I know that EU will implement a 0.5% limit on the sulfur from 2020. So all European waters will be 0.5, regardless of what IMO is doing. But pre-2020, this would be the scenario. And this Ro-Ro, here I've used, again, the variety where we have the specific oil consumption, but it's either or. But this Ro-Ro would obviously sail with 3.5% sulfur. They would obviously go for the cheapest fuel, which they get outside Europe, 3.5%. And for that vessel, with 80 days in an ECA and 40 days only in near coastal waters, Belgian coast, Port of Bremer and Hafen, Hamburg, maybe some ports in the Baltics, well, this is an ocean-going Ro-Ro, so it wouldn't go into the Baltics. It would stop in typically Rotterdam or somewhere. So for this vessel, you see the return on investment is like 4.5 years. So there is no set equation that can give you a general answer. You have to input your own values. That was actually what I was planning to bothering you with.